In this session, we will see the Linux memory forensics. First, we will see the Linux memory acquisition, how to acquire the Linux memory, and then we will see how to analyze that memory using the volatility framework. Just to remember that the way Linux handles the memory or the RAM is different than what Windows does. So let us first try to see a couple of commands before we go for the acquisition of the Linux memory. The first command is related to IO mem. Once you run this, it will show you the memory ranges for different components. As you can see, it starts with the reserved, then system RAM, again reserved, video ROM, adapter ROM, and system RAM, and many other entries. We are interested in finding out the system RAM. So you can run the command with the grep pass the system RAM phrase to get only system RAM related addresses. So these two ranges shows how the system RAM is distributed, and as it is discussed in one of the theory sessions, the way Linux handles the memory and its addresses and the symbols is completely different than how the Windows does. So our first step is to acquire the Linux memory, and for that we will be using the Lime master. The Lime master is available on the GitHub, and Lime stands for Linux Memory Extractor, and it is an open source utility which allows you to acquire the RAM from the Linux machines. So we will use Lime master. I am using Ubuntu 16.04. I have downloaded the Lime master and then I have extracted it into my home folder. So the Lime master is now extracted and it can be seen here. So let us start with the first command. So I have moved to the src directory of the Lime master, and then I am running the command called make, and I should run this command with sudo if I am not the super user. It will perform some steps. At the end, you can see a file has been created with the name lime-4.10.0-28-generic.ko. Now this is very important and this is the crucial thing. So the number starting with 4.10 is the version of your kernel, and you can compare, you can verify it by running the command uname-r. So once you run this uname-r, it will show you the same number which has been used. So Lime has created a kernel object for the current version of your image. Now it is time to create the memory dump. So there is a command which you can use. The command is insmod, and again you should use it with the sudo if you are not the super user. This command will insert the module which has been generated with the Lime source. It is a .ko file, and then you want to create the dump. So you are passing the path where you want to create the dump. I am saying that I want to save my memory dump to the home parag and dump.lime, and format of the dump has to be in the Lime format. So once I run this command, it will start dumping the data, and I can go to the home folder and I can cross check whether a dump.lime file has been created. You can see that right now it's 8.9 MB, and again if you refresh it will keep increasing because it's dumping the data. The process of dumping RAM may take time based on the size of the RAM. It is always recommended that you store your memory dump into the external storage, because saving it in the disk of the machine which you are investigating can hamper the existing data. So once the dump file is created, you can transfer it to the investigator's machine. I have transferred it into my Windows desktop, and I'll use the dump there for the volatility investigation. So there are 3 steps to summarize. First, you download the Lime master, go to the src folder and run the make command, and the third step is to use insmod. In case if you have taken the dump and it has not been taken properly and you want to retake the dump, then in that case you should remember 2 other commands. The first command is lsmod. So all the mod related commands should be used with the sudo. So once I run this lsmod, it will show me the modules which are being loaded. I can use grep to find out whether the Lime is loaded or not, and you can see that Lime module is already there. So in that case, before taking the RAM dump, where you will need to insert the module, then you can use the rmmod lime command to remove the Lime module from the kernel, and then again you can use insmod command to get the dump of the RAM. So let us go to the Windows machine and let us see how volatility can be used for the memory forensics. So we will use the volatility 3 for this practical. The earlier version was Volatility 2.6. Now in the last year, Volatility has released the third version, which has new features and it is more user friendly. So you can download the file from the given URL. I have downloaded it and I have stored it into the Volatility 3 folder in my D drive, and then I can go to the command prompt and I can use the commands from there. So the new things which have been implemented in the Volatility 3 are very interesting. The first of them is the removal of profile. Now you don't need a profile because it automatically detects the profile based on some other dependencies. We will see these things in few minutes. And the second major change is, since you don't need profile, you don't need to worry about the image info or KDBG scan, which were the hurdles in the earlier versions. However, the Volatility 3 does not require any profile, but there is a dependency where you need to provide the system map of the debug symbols. So they have introduced a new concept of the symbols where you have to keep the symbols of the kernel from where the dump has been taken. They have provided some sample symbols for Windows, Linux and Mac, but they don't include all the symbols. And for Linux mainly, or for the Mac, you can use the dwarf to JSON utility, which is a specially created utility, and it can be used in combination with some other dependencies like Golang, where you can download the dwarf to JSON, then you can build the dwarf to JSON using Go, and then you can run the command dwarf to JSON Linux dash elf. So you have to get the symbols. By default, the debug symbols are not available in operating systems. You can download them from the concerned repository. Say for example, let us go back to the Ubuntu and let us run the uname-r command. My version is 4.10.0-28-generic. You can download the file from the launchpad.net, and based on the version of your kernel, after you download it will be in the Debian format, so you can run the file and you will be able to see the generic file with the version in your user lib debug and boot, and then you can execute this command to get the output.json file. You can rename it with the related image file name, and after having JSON file you can convert it to exe file. The steps are given here, and we will see it in one of the upcoming videos, how to create the profile and how to use them. For this video we will be using an existing repository. So it has been created by panda-re from mit.edu. The research team have done very good job by creating various profiles for the Volatility 3 requirement, and all the profiles are available in the exe format, and you can see that most of them are created on 25th April. So recently they have created, and if you want to download all the profiles irrespective of whether you need it for any of the versions, you can use the ubuntu.tar, which contains all the Ubuntu profiles, and it is of around 2.8 GB. So after you download this profile, you have to copy those profile into Volatility and symbols, and in symbols you can create the Linux folder and then you can paste the profiles. My version is 4.10.0-28-generic 64. So either you create this system map or the profile by yourself, or you use the existing profile for your experiment. I have used the existing profile and it worked very well, and that has reduced a lot of time. So you can also think in the same direction if you do not have the sufficient resources like a separate dedicated machine, because in virtual environment it fails many times and it becomes a cumbersome job to create the profile. So you can take the advantage of existing profiles. So now I have this available in my Volatility 3, and if I go to the command prompt and if I want to run this Volatility 3 commands against the dump file which I have created, which is dump.lime, I have to run the command as I was doing earlier. So let's first write the python vol.py-h, and once you run this command it will show you the help for the Volatility 3. There is another change in the Volatility 3 compared to the earlier versions. Here in this version you don't see the profiles as you had been seeing earlier. If you move down at the end, you can see some non things, like you can see PS list, but the way PS list was used earlier is now changed. Now it can be called like windows.pslist.pslist, and you must have observed that P and L in the PS list of the last segment are in the capital letters. Similarly, if you go for the proc dump, windows.procdump dot proc dump, again P and D of proc dump are in the capitals. So these are all Windows plugins. If you go up, you can see Mac plugins, and then if you go further, you can see the Linux plugins. So in all plugins, they start with the name of the operating system, then the command in the small, the plugin name in the small, and then the plugin name with the capital letter. So let's run our first command. We want to see PS list. So let's say python var.py -f dump .lime, which is the dump file I have taken from my Ubuntu 16.04 machine, and then the command linux.pslist.pslist. So now you can use linux.pslist.pslist command as written here, and once you run this, it will first try to find out the profile from the available directories, and then it will start working on the plugin. And if the profile is set properly, the system map is matching with the operating system from where the RAM dump has been taken, then you would be able to see the output properly, and it shows you PID, PPID and COMM. So you can see the list of processes and their process IDs with the parent process ID. Similarly, you can run the other commands like linux.pstree.pstree, and don't forget to use the capital letters of each word in the final segment of the command. Now you will be able to see the tree structure there. Let us take one more command. So we can use the bash command, which will show you all the commands typed in the shell. It shows you the process ID, process command type, and command time, and the actual command. So you can see that I first used the cd lime master, and then I used ls, and this is how the commands have been captured. So to summarize, the first part is to acquire the Linux memory, where we used the lime master in the Ubuntu 16.04 version, and then we used the existing profile for Volatility 3 created by MIT.edu, and then we saved these profiles into the symbols folder of the Volatility 3 under the Linux operating system, and then we used the command with the new syntax given by the Volatility 3. Volatility 3 is still in the beta version. As you can see, its version is 1.0.0.beta, 0-beta, and its final version is expected to be released in the month of July or August this year. However, it has been become very easy now, as they have removed the profile and the image info related commands. So you can check with the other operating systems, and you can explore the options of dwarf to JSON to create your own profile. Since it's not a mature product, you may struggle in getting your own profile, but most of the time it works well. So this is how Linux memory forensics can be done using the Volatility 3 framework.